Hello guys, welcome back. This is Sakshi Kakade, and in today's session we are going to see what is stack and how does it works. So let us first see where stack exactly comes in data structure. So firstly, the data structure is divided into two parts. The first one is linear data structure, whereas the second one is non-linear data structure. Linear data structure are those in which the data is stored in a sequential order, whereas in non-linear data structure, the data is not stored in a sequential order. Again, the examples of linear data structure are: the first one is array, the second one is queue, and the third one is stack, which we are going to see in today's session. So let us first see what is linear data structure. In linear data structure, data is arranged in linear sequence. As I have told you in the earlier slide, whenever we are going to store data in the linear data structure, they are stored in a sequential order. Again, in linear data structure, elements are accessed or placed in continuous memory location. As we have seen in the earlier sessions of arrays, whenever I am going to store data into my array, the elements are stored one after another. That is, they are stored at continuous memory location. So, stack is also an example of linear data structure. Now let's move ahead and see what is stack. A stack is called a last in, first out or LIFO collection. This means that the last thing we added, pushed, is the first thing that gets pulled or popped out of. Let us suppose take the example of stack of plates. The plate which is placed at the top will be taken first, while the plate which is placed at the bottom will be taken last. So this exactly works the same how stack works. Again, a stack is a sequence of items that are accessible at only one end of the sequence. Let us suppose that this is my stack. Whenever I want to perform any of the operation, either it is of insertion or deletion, I can perform that operation only through one end. That is, I will perform the operation only through this end. So this is how the stack works. Now let us see some of the examples of stack. Stack of dishes, stack of books, stack of plates, stack of chairs, and stack of stone. These are the example which works exactly the same as like stack. Now let us move ahead and see what operations we can perform on the stack. Top. The open end of the stack is called top. From this end, item can be inserted. Top is one of the important element when we are talking about stack. So basically, the topmost element in that stack is called as top. When we are implementing our stack with array, at that time the address position of the topmost element is called as the top of that stack. Whereas when we are implementing our stack through linked list, at that time the address of the topmost element is called as top. Let us see the operation. Push. To insert an item from top of stack is called push operation. The push operation changes the position of top in stack. Whenever I want to insert any of the element into my stack, at that time the operation is called as push operation. Let us suppose that this is my stack and I have one element in it. The element, let us suppose, is 2. In this case, as there is only one element, the index position will be 0 and my top in this case will be 0. When I am inserting one more element into my stack, let us suppose the element is 3. At that time, my top is changing from 2 to 3. And my index position now will become from 0 to 1. That is, in this case my top position will be 1. So whenever we are inserting the elements into the stack, the position of the top in stack is changing. The next operation is pop. To put out, get or remove some item from top of the stack is the pop operation. We can pop only from the top of stack. Whenever we want to put out any of the element from the stack, at that time the operation is called as pop operation. And as we have seen, we can perform both of this operation only from the one end. Is empty. Stack considered empty when there is no item or element in it. Is empty operation returns true when no item in stack else false. Whenever my stack is empty or whenever there is no element in my stack, at that time the top will point to -1 as there is no element in the stack. Is full. Stack considered full if no other element can be inserted on top of the stack. This condition normally occurs when stack implemented through array. As we all know that array is static, so we cannot include more elements into it. Let us see with an example how we can perform the operation, that is push and pop. Can you guess guys which operation I have performed over here? Yes, this is push operation. I have pushed one element, that is element 30, into my stack. Now, as this is first element into the stack, the index position is 0. So, in this case, the top for my stack will be 0. Whereas, the top of stack or the top of 0th element will be 30. Let us insert one more element into the stack. So, my next element is 27. And as I have inserted one more element into it, now my top changes from 30 to 27. Now my topmost element is 27 and the index position for that is 1. So in this case, my top will be 1. Remember this point, whenever we are inserting elements into the stack, the index position is increasing or it is changing by 1. Again, I have inserted one more element into my stack. Now, the top will change from 27 to 98 and the index position for this element is 2. So, in this case, my top will be 2. Again, the index position have changed from 1 to 2. So, this operation which we have performed is push operation. Whenever we put out some of the elements from the stack, at that time the operation is called as pop operation. So what is basically top? Whenever we are implementing our stack through array, at that time the index position of the topmost element is called as top. Whereas whenever we are implementing our stack through linked list, at that time the address of that current element or the topmost element is called as top. So what is stack of top? The element which is present at the topmost position is called as stack of top. If there is no element 98 present in my stack, at that time the topmost element is 27. So at that case, the stack of top will be 27. Let us move ahead and see some more example for your better understanding. So in the first case, the stack is empty. So when my stack is empty, at that case, the top will point to -1. Remember this point, whenever my stack is empty, my top will be -1. In the next case, we are pushing element 8 into the stack. So, as we have pushed element 8 into the stack, the index position for this will be 0 and in this case, my top will be 0 and my stack of top will be 8. Again, we will push element 14 into the same stack. So, in this case, as 8 was present earlier, again we have pushed element 14. So earlier my top was 0, but now the index position has changed from 0 to 1. So in this case my top is 1 and my stack of top will be 14. Again we are pushing element 12 into the same stack. Earlier it was 8, then 14, and now we have inserted element 12. So in the earlier case my top was 1, but as I have pushed one more element into it, my index position has changed from 0 to 2, and in this case my top will be 2, whereas my stack of top will be 12. So we will pop out the element 12. So whenever we pop out the element 12, so in that case we will have only the 2 elements into the stack. Now as I have popped out element 12 from my stack, the index position will decrease. That is, earlier my top was 2, but now it has become 1. So remember this case, that whenever we are pushing elements into the stack, at that time the top position will increment by 1, whereas whenever I am popping out the elements from the stack, at that time the index position will decrease by 1. Again I am popping out element 14 from the stack. So there will only be one element into my stack, that is 8. Now as my only one element is present in the stack, so the index position will decrease by 1 and it will now become 0. So in this case my top will be 0 and stack of top will be 8. Now I am pushing one more element into the same stack. After pushing element 6, earlier 8 was present and now I have pushed element 6 into it. So earlier my index position was 0, now it has incremented by 1, and in this case my top will be 1 and stack of top will be 6. Now I have popped both the elements, that is 6 and 8. So in this case my stack will be empty. And I have said in the first case that whenever my stack is empty, in that case my top will point to -1. That is, whenever my stack is empty, my top will be -1. Let us move ahead and see the stack implementation using array. Whenever we are pushing element into the stack, at that time you must remember these two conditions. That is, whenever I am pushing elements into my stack, first I have to increment the value of top, and second the value of top is changing. That is, let us suppose one element is present in my stack, that is 8, and I am inserting one more element into it, that is 2. So in this case earlier the index position was 0 for this and hence the top was 0, but now as I have pushed one more element into it, the index position has increased from 0 to 1 and my new top is now 1. So whenever I am pushing the element into my stack, we have to increment the value of top by 1. In each case we have to increment that by 1 and the value of top is changing. That is, earlier my value of top was 8, but as I have inserted element 2 into it, my new value of top is 2. So this is how push operation works. Let us see how we can write the program for that. First we have to write void push for the function, and we have to check if top equals to 4. That is, if my stack is full, we have to check the condition. How can we check the condition? If the top equals to 4, in that case my stack will be full. Else, when my stack is not full, we have to give a message to the user that please enter a value. And as I have said you these two conditions, these are the exactly same. That is, we have to increment the value of top, that is top equals to top plus plus, and value of top is changing, that the stack of top, that is the value of top, I am changing to that. So this is how we can perform the push operation while implementing the stack using array. Let us move ahead and see how we can perform the pop operation in stack. First, we have to choose the value of stack as top, and The second one is that we have to decrease the value of top by 1. Let us suppose that there are two elements into my stack. The first element is 8 whereas the second element is 2. In this case, my top will be 1 and stack of top will be 2. But whenever I am popping out one of the element from that, let us suppose I am popping out 2. So in this case, earlier my top was 1, but as I have popped the element 2, now my top will be 0. So in this case, the value of top has been decreased by 1. So these are the two conditions which works while we are performing the pop operation by implementing through arrays. So this is the program. How can we write the pop function? We have to write the function as void pop. Then we have to check whether my stack is empty or not. And how can we check that? If my top equals to -1. In the earlier examples, I have shown you that if my stack is empty, in that case, my top will point to -1. So we can check that using the condition if top equals to -1, in that case we have to print my stack is empty. Else, if my stack is not empty, then we have to perform this two operation that I have mentioned over here. So this is the way how we can write the pop operations code. Let us move ahead and see how we can display our stack. So this is very easy how we can display our stack. This is exactly how we can display our array. So firstly we have to write the void display function. Then we have to check either our stack is empty or not, and we can check that using this condition, that is if top equals to -1, then my stack will be empty. If this statement becomes false, that is my stack is not empty, in that case using a for loop we can display the elements which are present in the stack. So this is how we can perform the operation, that is push, pop and display into a stack which is implemented by array. So this was all about today's session. Hope guys that you have cleared now with this concept of stack. So thank you for attending this session. Thank you.